Okay, so I wanted to make a video and either explain or try to clear up what I was doing here in class today. I wanted to try to explain this formula for compound interest, and I didn't quite get that across today in class, so let's try it one more time. And take the same type of example I used. We talked about a compound interest account, and this account pays 10% annually. And I talked about my great-great-great-grandfather investing in this account 100 years ago with $100. And let's see what would happen during the first year. So first year, what happens is you take the $100 and you times it by the percent, and since a year went by, you use 1. This is simple interest right here. Okay, that's how you compute the first years of interest. So you take 100 times 0.1 times 1 is times 1 is just itself, so I'm not going to worry about that. And 100 times 0.1 is 10. And I take that $10 and I add it back to the 100. So at the end of year 1, I would have $110. And I do this by year because it's annually. So at the end of year 1, I'd have $110. Now, I don't know if you recall, but we talked about how you could compute percentages like this a little bit easier. You take 100 times 1.10. Remember, if you put the 1 in front of it, basically it does this adding part for you. If you take 100 times 1.10, then you get 110. Now what I want you to do is hit pause and type these numbers in the calculator and make sure you're getting those as we work our way through here. So what I'm going to focus on is this method right here, where I multiply by 1.10, because I don't want to add every step of the way. Okay, so let me do it again with that method. Take 100 times 1.10, and this is going to be year 1, and I get $110. Okay, year 2, we have $110 in our bank account. So that's the reason why this is different than simple interest, is because simple interest doesn't take into account your interest. So we're going to take that $10 and put it back into the account. We have $110. So year 2, we're actually going to gain interest on $110. And that'd be $121. So make sure you're pausing that and getting these numbers. At year 3, you take $121. That's what's in your account now. Times that by 1.10. I don't want to add, so that's why I'm using the 1 point times 0.10. So I think, excuse me, so just because this is a video, it should be $133.10. I want to make sure of that. So I'll grab my calculator and make sure. I hate to make a video and it'll be all wrong. Okay, so 121 times 1.1. Yep, $133.10. Well, I don't know about you, but I'm kind of seeing a pattern here, right? See how every time I'm going to be multiplying by 1.10 every time. So I see that pattern evolving. But here's the part that I was trying to get across in class, but didn't quite get there. Okay, see how this 110 is equal to 100 times 1.10, right? This is equal to this. Well, here's 110. This 110 is the same thing as this right here that I have in red. So what I'm going to do is I'm going to replace that 110 there with a 100 times 1.0. Remember that they're interchangeable. It's equal to this. So that 110 becomes 100 times 1.10, and then times 110 equals 120. I just rewrote it. Okay, now you type that in your calculator, and it should give you 121. 100 times 1.1 times 1.1. What did I do? Too many decimals. See, 121. So that's cool. Now check this out. 121. Let me see if I can get my color straight. 121 is the same as this big long thing here. It's the same. Check it out. Here's a 121. right there. A 121 is the same as this. So I'm going to rewrite that 121 right here in yellow as what I have underlined here in red. 100 times 1.10 times 1.10. Okay, that's that part I had in red. That's the same thing as 121 times 1.10. Now check it out. If you multiply this whole thing together, it'll give you the same number. It has to, because I just interchanged things around. So 100 times 1.1 times 1.1 times 1.1. 133.1. See, it's the same thing. So I don't know about you, but there's a pattern here. See how many of these 110s you got? There's 3 of them. And what year was it? It was the 3rd year. Now, if you can't just say times 3, because you're saying this times itself 3 times. And when you take something times itself 3 times, that's a power. So this could be rewritten as 100 times 1.10 to the 3rd power. All right. So your formula that's given on that paper, A equals P times 1 plus R over N NT. Well, principal, well, that's that guy. That's what we started with. That's what we started with, $100. So we're going to start with $100. So that's where that P comes from. That's what you start with. 1 plus, well, that's the reason the 1's in there is because it's the trick. Excuse me, I put the 1 in there because I don't want to have to add this every time. So I just do this little multiplication with a 1 up front, and I get the answer without having to go back in my calculator and add. So that's where the 1 here comes from. The rate, well, that's what our rate was 0.10. Now let's end business. We'll talk about that here in a second. And then T is time in years. So that's where that 3 is. So the ends, well, there might have been an account, instead of it being 10% annually, it was going to be 10% semi-annually. So what happens is, semi means that it's on the halves. So half a year goes by, we take our interest and put it back in our account. And then half a year goes by, 6 months basically, you put it back in. So what happens, instead of me doing year 1, year 2, year 3, like on here, year 1, year 2, year 3, well, in this case, it'd be year 1/2. Be half a year gone by. 100 times, so half a year goes by, and it's 10%, right? But only a half year has gone by. Well, what is 100 times 10? Well, you can multiply these two guys first if you want to. 0.10 times a half is 0.5. 0.05. So it seems to me like whenever I do this calculations, I take half of my rate to get $5, and then you add it back to your 100 like we did a second ago. You got 105. So whenever the question says that something is semi-annual or quarterly or monthly, you have to take your rate and split it up. Either divide it by 2 or divide it, if it was quarterly, you divide by 4. If it was quarterly, if it's monthly, you divide that by 12. And that's where this n comes into play. That's where the divide by n comes. This is your quarterly or monthly or daily or whatever. Now up here you're thinking, well, why do you need an n there? Well, the same idea. Let's see what would happen if it was 3 years, but instead of I'm sorry, instead of annually, like I calculated here, it was semi-annually. So instead of this business where I have to add, okay, year 1/2, I'm going to say 100 times 1.05. Remember how if you put a 1 in front of it, you don't have to add these two things back together. You get 105. Now at year 1, see there's another half a year goes by. You have a full year now. You take 105, and then you multiply that by 1.05. The numbers are going to get a little bit, they're not so nice. Delete all this off. So I take 105 times 1.05. I get 110.25. Well, 110.25 is what we have in our account now. And this would be after year 1.5, 1.5 years gone by. So 110.25 times 1.05, 115.76. Okay, year 2. So you've had half a year, 2 halves, 3 halves, 4 halves. Year 2. So there's 115.76 in your account times 1.05. So what times that by 1.05? 121.55. So now you got your 2.5. So I take 121.55, 1.05. So 121.55 times 1.05. You get 127.63. And then at year 3, well, it's 127.63 times 1.05. So 127.63 times 1.05. 134.01. So see how many compoundings I had? It was twice a year, semi-annually. So we had 1, 2, 3, 4, 5, 6. Well, before I just had a 3 here because it was annually. Well, if I do it semi-annually, or it's twice a year, well, 2 times 3 in the formula will give me my 6 compoundings. Now check out my difference. I had $133.10 versus $134.01. I made an extra $1 by signing up for this one that compounds semi-annually. And you know what? If the account had been quarterly, if this number would be even higher. If it was monthly, this number would be higher. It gets higher and higher and higher. So what I would do then is you can memorize a formula if you want, but if you wind up with a question, let's say the question says you have an account that is 6%, it's compound interest, and then I don't know, let's say you kept it in for 4 years, and the terms were semi. Well, you can use that formula if you want, but think about it. I'm gonna take my $100. Let's just say we invest $100. So my investment is that first thing. I say 1.06 if it was annually, but this is semi-annually. So I got to take half of that. So 0.03. Now, how many compoundings would I have in 4 years if it's semi-annual? Just like over here, how many compoundings would we have? Because there were 6 in there. Well, this time it's semi with 4 years. Well, that means 8. There's 8 compoundings. So I don't particularly stick with the formula. I mean, you can, but you don't have to. I mean, you just kind of think it through. So you just multiply this up, and you get your answer.